Hey everybody, this is Coach Brian going over the 4.3 notes. These notes are all about rotations, and we're going to talk about how to rotate figures, objects, points, etc. And so we start off just by establishing what a rotation is. And so for the first example, it says to tell whether each transformation appears to be a rotation. And so if I'm looking at this first picture, it actually, just looking at corresponding pieces of it, they kind of mirror each other. And so that leads me to think this is a reflection, which is what we covered last class. If you're not familiar with reflections, you'll need to go back and watch 4.2 notes. But then if I look at B, it really does look like I've just taken, if I say my blue is my original, it really does look like I've just taken that object and kind of turned it. Or if red was the original, maybe I've just gone the opposite direction and turned it back, towards the left. And so when we're rotating objects, all right, we are performing a transformation. And what we're doing is we're taking each point, takes each point, and what it does is it rotates them around a given point by a number of degrees. And so this is where, it's really important that hey, there's 360 degrees in a circle. I cannot draw arrows. There's 360 degrees on a circle. You could go either way. So obviously a quarter of a circle is going to be 90 degrees. Half turn is going to be 80. 3/4 is going to be 270. A full turn will be 360. And obviously there's all the angles in between there also. In this definition, we talk about this given point, and that point is the point of rotation. So we define that as the central. That's key right there. It's in the center. It's central, and it's fixed, meaning it's not moving. And this is the central fixed point around which a figure rotates. So if we go back up to our example 1B, you can kind of see that this point on that image is kind of like the pivot point. It's the point where all this moving and this rotating happens. And lastly, we have the angle rotations. It's going to be, how far you rotate something, but it's also going to be which rotation or which direction the rotation happens. So it's angle given with degrees and direction. And so by that we would do clockwise or counterclockwise. All right, so in our second example, we are performing some rotations. It says find each of the following images. And we have, this kind of complex image here. It's got a lot of different points in it. And it says first to find the 90-degree clockwise rotation of image C. So as we're looking at image C, we would take really our point here and our center point, and we would take our image clockwise, so like you're going around the clock, 90 degrees. So what you see here would then be rotated 1/4 turn. Okay, that's 1/4 turn, a fourth of a circle, clockwise, like you're going around the clock. And so if we're looking at this, our pre-image would be our pre-image would be at C, and our image, which is our after image, C would move over to D. Like everything over here would shift to this position, and your whole picture would rotate based off of that. Next, we are taking a 180 degree, that's a half turn rotation of line EF. So we've got this line right here, and we want to rotate it not a quarter turn, but a half turn. And so where would it end up? Well, if we take this and we rotate it half of a turn, it brings us actually over to where HG is. Okay, hopefully that makes sense to you. Taking this side and moving it to this dotted line I'm making right now is only 90 degrees. Moving it to the solid red HG is 180 degrees. Next, we're going to do a 90 degree counterclockwise rotation of line AH. So first, we got to find AH. It's this diagonal right here. And we want to take it a quarter turn counterclockwise. So we're going to take it and go this direction. Sorry, I made that big loopy arrow. I'm just trying to keep everything from getting too crowded. And so when we rotate AH 90 degrees counterclockwise, it brings us over to DG. And then lastly, we've got 90 degrees clockwise of AD. So if I find AD, it's this whole side right here that I just colored in purple. It's going to go 90 degrees to the right, which will bring it up to where we find AB. For our third example, it says rotate this figure 90 degrees clockwise about X. So this point is central and fixed, meaning it's not moving. And so if we took our image and we took all the points, all right, think about these corners as like coordinates, okay? If I had all of these on here, and we'll give ourselves a little reference here. If I was to take every one of those points and rotate it 90 degrees clockwise, you have to think, what would this shape look like? Okay, what would this shape look like? 90 degrees clockwise. And so what it would do is it would pull this corner, I'm going to make everything blue now, over here, okay, that corner over there, this corner over here. Sorry, that wasn't great. Right about there. They are straight. This one over here, and this one over here. So I know that's real messy looking, so I'm gonna recap now that I've explained where everything's going. Your points would end up about here, and our shape would look as follows. It would be a 90 degree clockwise rotation. All right, now we get into kind of the rules of things. When you're told to rotate this way, that way, whatever, can you do that without necessarily drawing a picture or a graph every single time? Are there any rules? And there are. And we'll start off just with some points, okay? We have this image here in black, and I'm just gonna go highlight all of its vertices in yellow, okay? And those points, A, B, C, and D, are actually already graphed for us here, and they're already plotted for us, so we know what their coordinates are. And so what we want to do is make each one of these rotations by drawing and then see if we notice anything about the pictures. So if I took point A and I rotated it 90 degrees clockwise about the origin, point A would now be over here. If I did the same thing with point B, it would now be over here. Go ahead and get this guy out of the way. Then, if I took point C and rotated it around, it would be here. And if I took point D and rotated it around, it would be here. So if I trace this out, try to make it look nice. If I trace this out, the red image is the original rotated 90 degrees clockwise. So let's actually plot these points. I'm going to highlight all the vertices in blue just so they kind of stand out. Let's record them and see if we notice any difference or any patterns. So starting with A, it was over at 5, -2, and it moved to -2, -5. B moved to 3, -5. C moved to 3, -3. And D moved to 0, -2. So you might already be seeing some kind of pattern here, but let's see if we can get some more information before we get any conclusions. In our next column, we want to rotate 90 degrees counterclockwise. So we want to take this image and go 1/4 turn counterclockwise. Every time I record. All right. So I'm going to go kind of quickly through this, but once I move all my points over, they actually end up at C, B, A, and D. And when I trace those out, that's not good. When I trace those out, connect them all, you can see my image. I haven't changed anything about it. That's important. You shouldn't be changing shape or size or anything. But when I do that, I've now got a 90-degree counterclockwise rotation. And really quickly, looking at its corners, they are at 2, 5. They're at -3, 5. They're at -3, 3. And they are at 0, 2. And then let's do one last one. If I wanted to rotate this 180 degrees, so I'm going to take this image and move it over to this side of my graph. And the orientation and everything, like I said, no matter which way you go, okay, no matter which way you go, if you go all the way counterclockwise or if you go all the way clockwise, all right, our orientation should end up being the same. And so what we end up with is points at -5, 2. Oh, sorry, I put that at -2. -5, 2. -5, -3. -3, -3. And -2, 0. And if I connect these points, you'll see my image has been rotated 180 degrees. And just to go over those points again, they're -5, 2, -5, -3, -3, -3, -2, 0. All right, so after looking at these rotations, we can kind of develop not really a pattern, but kind of a rule for how they work. So when we're talking about 90 degrees clockwise about the origin, all right, let's just to show you real quick here. If we were starting on this axis, we're going 90 degrees clockwise. That's where we'd end up, right there. And these rules are actually going to also apply to 270 degrees counterclockwise because they bring you to the same spot. Okay, so I just want to point that out to you if you get any 270s and 90s. All right, if I were to take this 270 counterclockwise or 90 degrees clockwise, they take you to the same spot. So this particular rule, you're going to swap your X and Y, and your X is going to be negative. For the next, same thing here. If you took a point, let me make that a little more even. If you took a point, let's just say it's down here, and we moved it 90 degrees counterclockwise, that would be the same thing as 90, 180, 270 clockwise. And so the rule for this is you're going to swap your X and Y, but your Y will be negative. And then lastly, 180 degrees. This one's kind of nice because let's say we start with a point over here and we want to go 90, 180 degrees, or we could go 90, 180 degrees. So clockwise, counterclockwise doesn't really matter as much with this 180 degree rotation because you're going to end up in the same spot regardless. And for this, you keep your X and Y the same, but they're both going to be negative. So for 90s and 270s, you swap your X and Y. For your 180, they stay where they are, but they both become negative. So it'd probably be really helpful to keep this table handy as you do your practices and things like that. All right, we're going to do just a couple of these examples because I want you to do some of them yourself. I don't know why I can't get this to go off the screen. All right, so for example number 5, it says to find the image. And that's really important that you're reading those correctly each time. Like down here, see at 8, it says pre-image. And so remember, when you have your letter, okay, that's your starting point, your pre-image, okay, when it's just a letter. And then you apply some rules to that, and you get your letter prime, which is called your image. And so this is where you start, this is where you finish, and you need to be paying attention to, am I going from start to finish, or are they giving me the finish and I'm trying to figure out where I started, okay? So when we're looking for the image, we're going from start to finish, and we're trying to rotate it 90 degrees counterclockwise, 90 degrees, and we're going this way, counterclockwise. So let's go up to our rules real quick. To go 90 counterclockwise, we're going to swap our X and Y and make our Y negative. So using that rule, we would move our Y to the X position and make it negative. We'd move our X into the Y position. For our Y value right here, we would go swap our numbers and make our Y negative. Looking down at example number 8, we're trying to find the pre-image. That's where we started. And these points, A prime and B prime, have been rotated 90 degrees clockwise. So after this rotation, let's look at our rule for a 90 degrees clockwise. Y negative X. Y negative x. So what that means is whatever this original point was that we're about to find has had this applied to it. And so this 7 that's now positive 7 after its sign was changed was originally our x, and if it's now positive, that also means it was originally negative. And then nothing happens to the y, it just switches spots with the x, so when we switch it back, it's going to be -4. And so -7, -4, when this rule is applied, gives us 4, 7. And if you're ever unsure about a point, you could always just apply the rule to it and see if it ends up at this prime value. On 9, you're also looking for the preimage, and on 10, you're looking for the preimage. So that's going to be, where did I start? Okay, where did I start? This is my finish. How did I get there after applying the rule? And then just to summarize, 90 degrees clockwise rotations. All right, so that's going to be clockwise. Require you to switch them and make your x negative. 90 degrees counterclockwise. Require you to switch them and make the y negative. And 180 degrees rotations, you switch them and make them negative. Just to kind of tie back into our other rule, that's the same transformation as a reflection across y equals -x. So some of these things will overlap, and some of them will start to, as we build and build and build on these transformations, you'll start to see how they all kind of fit together and how some things can be accomplished in multiple ways. So hopefully this helps, and make sure you get your notes finished. Thank you.